I'm going to go through this fairly quickly. Really, I'm just going to talk through some of the examples, but showing you the correct answers. Alright, so this one, to factor and solve, you have to use the factoring pattern, a plus b times a squared minus ab plus b squared. Then you set both those equal to 0 and solve, and when you do that, you end up getting this expression. The 12 square root of 3, I think, was the square root of 432i, so I just simplified it. This one, there's 4 terms, so you have to factor by grouping, which I did there. Also notice that I'm expecting that if you have a difference of squares that you do take that one step further before you give me your 2 answers, or actually in this case 3. And here, move the 10 over, then I factor like I would a quadratic, and then set both those equal to 0, and when you do that you end up getting plus or minus square root of 5 and plus or minus square root of 2. For number 2, you're given 3 dimensions to find the volume of a box. It's length times width times height. So height is x. This is my width because it's 1 foot less than the height. 4 feet less than the height is my length. So height times width times length equals the volume, which is 20. Then I foiled those together, distributed the x through, and moved the 20 over. And then I have 4 terms, so I can factor by grouping. And then once I get down here, the only answer that makes sense is 5, because the other ones would be imaginary. So then I take the 5, and then that would be my height. 1 foot less would be 4. 4 feet less would be 1. So those are my dimensions of the box. Flipping. For number 3, again, this one you have to factor by grouping. Well, leading coefficient, determining the end behavior, down then up, should be your end behavior. I factored this, so I set equal to 0 to find my x-intercepts. The only x-intercept I end up having is 5 halves. So then I plot that, which is 2.5, and I picked 1 point to the left, 1 point to the right, and plugged those into my equation to find my y values. And then I plotted those. There's just a very slight curve through those 3 points, but I should see not a straight line, but a slight curve. Domain and range is all reals. For the second one, factored it like a quadratic. Here, this I could factor into x minus 2 times x plus 2, so plus or minus 2 is your answer there. And here, I get plus or minus square root of 6. Now, I didn't cross it off necessarily, I just punched out square root of 6 to get 2.44. So I have 4 answers. I plotted those first. Then I selected the in-between point. So between positive 2 and negative 2 is 0. Between positive 2 and positive 2.44 is 2.22. And between the negative version of those is negative 2.22. And then I plugged those 3 x values in and got these 3 y values. Plotted those, and then you end up getting a W shape when you connect all of them together. Here, determine the end behavior. Factor by grouping because you have 4 terms. You end up getting a difference of squares, so I factor that further into x minus 3 and x plus 3. So I get 3 x-intercepts, plot those. Then I find my turning point, so halfway in between 3 and negative 3 is 0. Halfway in between 3 and 5 is 4. So I plug those in to the original equation, get my 2 y values, plot those, and then connect points. And for number 4, this one you can't factor. So I made a big table of values. I think I only plotted from 4 to negative 4 because those are the only ones that easily fit in the graph. And then you end up having this figure. Okay. And then flip graph 1. That should be your work for both of them. I don't really know what I can do here to explain it, except like to get this, you'd have what times x squared gives you 7x to the 4th. So 7x squared would go there. And then you have to multiply by negative 3 in order to get the next term. And notice I lined it up, so that's easy to subtract. So you end up getting 18x squared, because remember when you subtract a negative, you end up adding. then you go back up to the top. What times x squared gives me 18x squared? 18 times negative 3 gives me negative 54. 1 minus the negative 54 gives me 55. And then that would be how you want to write your answer. Same thing for B, same process, and you should get that as your answer. Number 6, synthetic division. Remember, when you're dividing, it's the C value that goes in the box onto the left. List all your coefficients. If you're missing a term, make sure you put in 0. Then bring down the first. Negative 2 times 4 gives you negative 8. Add, multiply, add, multiply, add. So you end up getting this as your answer. And then for number 7, this one with all the crazy fractions. But in order to determine any of them, you ask yourself the question, what times 2 gives you 3, or the coefficient? So this is what I'm doing in my head. What times 2 gives me 3? And so if I solve for x, 3 halves times 2 gives me 3. And then 3 halves times negative 1 is negative 3 halves. Then I subtract. And then what times 2 gives me 3 halves? If I divide by 2, you get 3/4. So I just did that process to get all those fractions, but that should be your answer at the very end. Again, remember, I'm going to go through this fairly quickly, but make sure you pause or replay or whatever as you need to. Okay, in the last page here, last standard that you're being tested on, remainder theorem, you're given a 0, so this is already an answer. And you plug that in. Notice I don't change the sign. We're not dividing. We're just using the synthetic division process to plug a number in. So I plug it in. It tells me if I plug in negative 6, I should get 0. So your remainder should be 0. If it's not, you did something wrong. Then you rewrite your depressed polynomial. And then, in this case, you could factor this one. But we're going to use I use the quadratic formula. So I use the quadratic formula, got this. Notice, hey, I have a square root. Got 7. And then I added 5 plus 7 divided by 4 to get 6. 5 minus 7 divided by 4 to get negative 1/2. So those should be my two answers there. And then for number 2, the only thing I didn't do on here is explain in a few sentences how we found the first 0. I graphed it on the calculator and then tried to find a nice grid point where it crossed, which was negative 5. So I used negative 5 first. And it actually benefits me to use negative 5 because my other two answers end up being decimals, so it would be hard to plug those in. So I plugged in negative 5, went through it, wrote the depressed polynomial, and then solved it using the quadratic formula. Okay. So that's all the answers for the test review. I will be here early tomorrow morning in case you have any further questions. After the test, since this probably won't take you the whole hour, we'll do any final testing of catapults that need to be done. And I'll have something else for you guys to do before spring break. So, thank you. This is Crisscross signing off.